Okay, starting with section 5.1. And I think what we're gonna do is we're gonna go through it so that the camera can take care of all that, and then we'll go back and we'll do some example problems before I give you your stuff. Okay, I'm not sure how we'll do it. If I have a to the negative n power, you know that negative on the exponent then takes it to the bottom location. If it was on the bottom, what would the negative do? It brings it to the top and you get rid of it. So then it's just a to the n power. So anytime you have a negative on the exponent, it changes its location. We talked about if I had like a negative 2/3 to the negative second power, what's the easiest way to do this? If I have a fraction,
Flip it.
I just flip it. Okay, I flip it, and when I flip the fraction, it gets rid of that negative. Then I proceed and go, oh, that's 9/4. Okay, and then I proceed and do the problem itself. Also in section 1, we talked about if you have base numbers that are the same and you're multiplying. So let's say I have x to the 5th times x to the 4th. What's that equal to? X to the 9th, okay? Because if the base numbers are the same, then I add the exponents. What if I have a power raised to a power where that second number doesn't have a base number? What do I do there? I multiply. So that's x to the 20th power, okay? What if I have division? What do? If the base numbers are the same, I subtract, and I get that. Now, what if I have this?
Over 1.
Okay, I can turn around and I can go, there's two different ways I can do it. I can still subtract the exponents. And if I did, I would have x to the negative 1 power, which then turns around and translates to 1/x. The other way I can do it is I can go, I'm going to subtract the smaller number from the larger number, and I'm going to place it where the larger number is. So I have 5 minus 4, which is 1, so I know I have an x left over. The larger exponent is on the bottom, so I place it on the bottom. You can look at it either way, okay? You can always subtract and then pay attention to those exponents, or you can just subtract and put it where the larger number is, okay? Now, notice you have front and back, okay, and hopefully you can read my writing. So there's some examples there on the top of page 2. The other thing that we talked about in section 1 is we talked about scientific notation. Now remember, scientific notation actually can be done on your calculator. Okay, you can change it to that scientific mode on your calculator if you want to. Scientific notation is always a number written between 1 and 10. Notice between 1 and 10, okay, not including 1 and 10, and a multiple of 10 of a power of 10. So if I have 4.25 times 10 to the 4th power, that's written as scientific notation. If I said write it in standard notation or decimal notation, that's the exact same thing, then what am I going to do?
Move back.
I'm going to move,
Calculations.
right, I'm going to move the decimal 4 places. I know a positive exponent is going to make this be a bigger number. So I know I'm going to move it to the right. So this would be that, okay? Because I move it 4 places, okay? And I plug in zeros where I need to plug in. If I, however, had a negative there, what would I do? I'd move it to the other way because I know a negative exponent makes it a smaller number. So then I'm going to move it to the left, and I still have to put zeros there. Let's see, 1, 2, 3, 4. But I've got to put my decimal there at the front so I know where the decimal lands, okay? If I have the decimal at the end of the number, I don't have to put it, okay? It's just understood that it's there. But if it's at the beginning of the number, obviously it has to be there for me to understand where the decimal is located. Otherwise, I assume it's at the end. You've got to be able to go both ways. In other words, if I give you Now, a problem like that, you could stick it in your calculator, and then you could go to mode, and you could change it to scientific notation, and it would change it for you, okay? Your calculator, though, has a window, and so sometimes automatically, if the number's too big, it'll just put it in scientific notation because it cannot go across the window, all right? So if I were to change this number to scientific notation, what would it be?
1.254 times 10 to the negative third.
Good. How'd you know it was a negative third, Joseph?
Because you're moving it, you're making it bigger.
You're making it bigger, and you know this is a small number. Okay, this is a small number, you're making it into a bigger number. Okay, if you think the reverse of it, this is a big number, I have a negative on it, so I'm making it into a smaller number. Check it both ways. Make sure you're understanding. Like I said, it works to go in your calculator. All right, and that's like the end of the first section. Let me actually give you a couple to try, just on a piece of scrap paper. Obviously, you don't have a whole lot of room on that study guide to do it on the study guide. Okay, I told you this was a long chapter. Okay. What? Okay, I want you to do this one. Okay, and I want you to do this one. And then I have a scientific notation one. Okay, it's actually a problem, and I want it expressed in both scientific notation and in standard notation. Okay, do those three. Obviously, you use your calculator on the bottom. Okay. Top one, you have, if you add the exponents, you have f to the negative third power, which is 1 over f cubed. Don't leave it like that. Okay, don't leave it with a negative exponent. It needs to be converted. All right, this one's a little trickier. Okay, you had to remember that anything to the 0 power is equal to 1. So this is a 1, this is a 1, this is a 1, and this is a 1. So I have 1/2 minus 2 over 1. You got to have a common denominator here. So it's the same thing as 1/2 minus 4 over 2. So I would have a negative 3 over 2 as my answer. Okay? This one down here, shortcut if you didn't want to pick up your calculator. Hopefully you know and remember this. Okay, if I look at everything besides zeros, I have 2 times 85, which is 170. And then I annex my zeros. So I have 3 zeros there and 3 zeros there. So I have 170 million. Then I have to put it in scientific notation, and I have 1.7 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8th power. And it's a big number, so I know it's positive. Okay? We good? All right, moving on to the second section then. Okay, and this is the bottom of page 2. Talking about polynomials. Polynomials, remember, we could classify, if they have one term, what are they called?
Monomial.
Monomial. Okay, that means it doesn't have any addition or subtraction in it. What's a 2-term polynomial called? Binomial. 3-term?
Trinomial.
Trinomial, and after that they just classify it as a polynomial. Okay, now sometimes they just classify binomial as a polynomial. Okay, they all fall underneath that polynomial heading, but after 3 terms they just blanketly call them polynomials. Okay, make sure you know how to find the degree of a polynomial. Let's say I have this polynomial. What's the degree of that polynomial? Don't think too hard. Go ahead, Joseph.
46?
It's 40.
40.
It's 40 because remember, to find the degree of the polynomial, you add the exponents up in each of the terms. So the degree of this term would be 7 because it's 2 plus 1 plus 4. The degree of this term would be 3. And then I made it easy for you because the degree of that term is 40. 40 is my largest number, so therefore 40 is the degree of this polynomial. Now, if I asked you for the leading coefficient of this polynomial, what would you say? 20. Okay? It's the term where I grab the degree. It's the coefficient in front of those variables. Okay? No matter what order it's in. Okay? Yes, no, maybe. It's not something we use very often, so that's just a refresher on it. Technically, to be a polynomial, you're not supposed to have a variable underneath the square root, and you're not supposed to have a variable on the bottom of a fraction. Now, I laugh about that because all the way through this, then we've turned around and worked with problems that have had square roots with a variable underneath it, and we've had polynomials where, and they're not technically polynomials, but they put them all in this chapter together. So if they go to say, is this a polynomial or not a polynomial, understand, if it has a variable on the bottom, the answer is no, and if it has a variable underneath the square root, the answer is no. Okay? Adding and subtracting polynomials, we've been doing this all the way through. So hopefully there's no problem on this. You're adding like terms. Okay, just make sure if it's adding, you add, don't multiply. Okay? Make sure you look for that addition thing. A lot of times they're going to put the parentheses in there. So the addition mark would probably be in the middle of the parenthesis. Make sure when you go to subtract it, you subtract everything. So in other words, you're distributing the negative. I'm actually going to give you a subtraction problem to do. Okay, the addition, I'm not worried about. I feel like there's no problems there as long as you're looking at the problem correctly. But let's make sure the subtraction goes as planned. All right, do that problem. Okay, I would, if I were you, I would go ahead and inside my parentheses, I would add the opposite of my second number anytime I have subtraction. Then I would go back through, and now I have subtraction in the center, so I'm adding the opposite of everything behind it. You don't have to do that if you want to do it in your head, but I guarantee you if you do it that way, you won't be messing up as often, okay? And maybe this is not an issue that you have, but you do it however's best for you to get it right. So I have 11x squared and a negative 7x squared, which is a positive 4x squared, and then I've done those two. Then I have a 13x and a 9x, which is going to give me a 22x. And then I have a negative 15 and a negative 19, which is going to give me a negative 34. So that's what you should have. Got it? Okay, then we moved on and we did multiplication. Now, on multiplication, we did like a monomial times a polynomial. So we started out with something like this, maybe. Okay, let's say I have that. That means I'm going to, because I have a monomial on the outside, I'm going to distribute this. Okay, and I'm going to multiply every single one of them. So that's going to give me 8 what? Into the fifth. Don't forget those rules that we just went over. If the base number's the same, you add the exponents. Plus 4 into the fourth, plus 8 in
Second.
to the second. And then you're done. Because none of those can be combined. Remember, in adding and subtracting, the exponents and the variables must exactly match. Okay? I don't assume there's any problems on that. Okay? Then we moved on to a binomial times a binomial. And that's where we brought in FOIL. Okay? So I have x plus 4 times maybe negative 2x plus 10. Okay, remember FOIL, first, outside, inside, last. The truth of the matter is, you can do distributive property on this. Okay, it works. FOIL is just that little term that they always use that makes it, in some ways, makes it easier. So when I do first, I get a negative 2x squared. When I do outside, I get a 10x. When I do inside, I get a negative 8x. When I do last, I get a 40. Most of the time, not always, but most of the time, you're going to be able to combine the outside and the inside together because of the way it's written. Doesn't always work though, so you got to make sure that they match up. These two do match up, and you end up getting that. Okay. All right. Let me give you a couple of these to do. Okay.